Hey, this is Mr. James, and in this video we're going to be talking about transversals. As always, make sure that you pause the video or rewind when you need to try a practice problem or miss something that I said earlier. And when you take notes, you can use the note sheet, a blank piece of paper, and you don't have to copy down everything I copy down. You can write down things I say or anything that might help you remember the information. So, let's start. First, what is a transversal? Well, a transversal is one line that intersects two or more other lines. So if you'd like to, pause the video here and try and circle which of these lines are transversals in these four pictures. Alright, so now that you've tried, here is a transversal. This line here is another transversal. It's cutting through or intersecting two other lines. This right here is also transversal. Okay? This time it's cutting through three lines, and this right here is also transversal. Now, like I said, transversals can cut through two lines, like in this one, okay? Or they can cut through three or more lines, like over here. A transversal, like this one, can cut through two parallel lines, or a transversal like this one can cut through two lines that are not parallel to each other, that'll intersect eventually. So like I said, transversals can cut through two lines that are parallel or not parallel. So we've got a parallel example here and a non-parallel example here. However, if the lines are parallel, there are certain theorems that we can use to do algebra problems, and we'll talk about this on the next page. But before we get there, we need to learn some special vocabulary terms. So we're going to use these two figures to fill in the vocabulary terms on the bottom of your page. Okay? So the first two vocabulary terms we've already learned before, vertical angles and linear pair. Let's look at our diagram, all right? And give an example of some vertical angles. Right here, you've got angle 1 and angle 3 are vertical angles. And vertical angles are across the intersection from each other, just like that. So those are vertical angles. So let me write down an example. Angle 1 and angle 3 are vertical angles. If you'd like to, pause the video here and try down some more examples of vertical angles. Here are some more examples of vertical angles that you might have written down. 4 and 2, 5 and 7, and 8 and 6 in our diagram are all vertical angles. For example, here's 8, here is 6. They're across the intersection from each other. They're vertical angles. And it works also on this diagram. 8 and 6 are across from each other. They are vertical angles. So whether they're parallel or not, they're still called vertical angles. Now let's draw a quick drawing so we remember what vertical angles look like. I like to draw two crossed lines, okay, and kind of highlight those vertical angles. And we have a special theorem that we can use with vertical angles. If you have two vertical angles and the lines are parallel, then the two vertical angles are congruent. They equal each other. But we already knew that. Let's write it down. Angle 1 would equal angle 3. Okay? We also know about a linear pair. A linear pair are any two angles that are adjacent to each other on the same intersection that add up to 180 degrees. So for example, angle 1 and angle 2 are a linear pair. Or you could say that angle 5 and angle 8 are a linear pair. Again, it works even if the lines aren't parallel. So 1 and 2 are a linear pair. They add up to 180 degrees. They're supplementary. And 5 and 8, those are a linear pair. They're supplementary, they're adjacent, they add up to 180 degrees. So let's write those down in our examples. Angle 1 and angle 2, and angle 5 and angle 8 are a linear pair. Go ahead, pause the video and see if you can write down a couple more examples of linear pairs. Here are just a couple examples of linear pairs, but there are a ton more on the diagram, so don't worry if you have different ones. To draw a linear pair, we can think if we've got an intersection of two lines. A linear pair are two angles that are adjacent, so perhaps this angle and this angle right here. And we already knew this, that if you have a linear pair, those two angles are going to add up to 180 degrees. So if I take angle 1 and angle 2 from my example, they should add together and add up to 180 degrees because linear pairs are supplementary. What about alternate interior and alternate exterior angles? Well, let's take a look at the diagram. Well, the word alternate means that we're going to pick one angle from this side of our transversal. Again, here's our transversal. Okay. We're going to pick one angle from the other side of our transversal. That's what alternate means, alternate sides of the transversal. So alternate exterior angles are two angles that are on the opposite side and are on the outside of the exterior of these two parallel lines. So the exterior is out here. This is the exterior. So angles 1 and 7 might be called alternate exterior angles. Let's write that down. So angle 1 and angle 7 are alternate exterior angles. We've written that down. Try and pause the video here and see if you can figure out another pair of alternate exterior angles. And hint, there is only one. Hopefully you guessed it. 2 and 8 are also alternate exterior angles because they are on the exterior of the two parallel lines, and they're on opposite sides, alternate sides of our transversal. So let's write those down. Alright, now that we've written them down, now we need a good kind of drawing or hint so we know what alternate exterior looks like. Well, if you draw your parallel lines and you have your transversal, then alternate exterior angles could be here and here, or I guess they could be, I'll draw a little star here and here. Those are alternate exterior angles. And if you notice, alternate exterior angles look like they're about the same size. They look like they're kind of the same angle. And in fact, they are. If two lines are parallel, then alternate exterior angles are congruent. They're equal. So just like with vertical angles, we can say that alternate exterior angles, angle 1, equals angle 7. Now, alternate interior angles are very similar. Let's go back to the diagram. Again, alternate interior angles will be on alternate sides of this transversal, so on two opposite sides. Okay, but now they're on the interior of our two parallel lines. Think about almost like a sandwich or maybe a house. We're in the interior. Okay, and so alternate interior angles might be something like 6 and 4. Those are alternate on opposite sides of that purple transversal, and they're interior of those two green lines. In a second, I'll write that down, but before we do, can you guess what the other alternate interior angle is? It's going to be 3 and 5. See how they're on the interior of the two parallel lines, and they're on alternating sides of our transversal. Let's write those down. So we've got our alternate interior angles, 4 and 6 go together, and 5 and 3 go together. So again, let's write down a little reminder of what alternate interior angles look like. Okay, we've got our parallel lines in our transversal. And remember, they're interior and they're alternate, so those two could be alternate interior angles, or maybe these two could be alternate interior angles, that one and that one. But as long as they're alternate and interior, you're good. And just like alternate exterior angles, alternate interior angles are congruent. So something like angle 4 would equal angle 6. Those two angles are congruent, they're the same size. So what about same side interior or same side exterior? Well, you can probably guess that same side interior and exterior are kind of like the alternate interior and alternate exterior, but instead of being alternate, the angles are on the same side. Let's look at the diagram. So a same side would mean that here's our transversal, but the two angles are going to be on the same side, either both on this side or both on this side, as long as they're on the same side. And a same side interior, okay, same side interior would mean that they're on the interior of these two parallel lines. Okay, so for example, 3 and 6 are same side interior. They're on the same side of that purple transversal, and they're on the interior of these two green lines. Can you find the other same side interior angles? Right, it's going to be 4 and 5. Again, they're on the same side of that purple transversal, and they're on the interior of those two parallel lines. Let's go write that down and draw a little picture to remind us. Right, so angle 3 and 6 were same side interior, angle 4 and 5 were same side interior. So here's a little drawing to help remind us. Right, same side and interior. So maybe those two angles, or this angle here and that angle there. Same side interior. And if you look at those two angles, they don't look like they're equal anymore. They don't look that way. But they do look like, if you put them together, they might create a straight angle. They might add up to 180. In fact, they are. They are supplementary. So we can write down, if you have angle 3 and you add angle 6, you should get to 180 degrees. That's it. Same side exterior angles are much the same, right? If you've got your transversal here, and you've got your two parallel lines, again, they're going to be on the same side of that purple transversal and on the exterior of those two green parallel lines. So 1 and 8 would be same side exterior. Can you find the other same side exterior? It's going to be 2 and 7. 2 and 7 are the other same side exterior angles. Let's go write those down and draw a picture. Right, so 2 and 7 are same side exterior angles. That's their pair. 1 and 8 are same side exterior angles. And let's draw another little diagram here. Again, same side, but exterior, outside of the parallel lines. So this little example here, okay? And again, same side exterior angles are going to be supplementary. If you know what those angles are, and they're parallel, then they will add up to 180 degrees. So something like angle 1 plus angle 8 will add up to 180 degrees. We've got one more to talk about, and that's corresponding angles. Now, corresponding angles are a little different. If you look at one intersection, like this one, let's look at angle 1. You look at the other intersection, at angle 5, those two are corresponding. They're both in the same position on each intersection. So like angle 1 is in the top left, and angle 5 is also in the top left. They're called corresponding angles. Can you figure out what the other pairs of corresponding angles are? Well, they would be 6 and 2 are corresponding angles. 3 and 7 are corresponding angles. 4 and 8 are corresponding angles. Let's go write down those pairs and draw us a little picture. All right, so here we've got our pairs of corresponding angles, 1 and 5, 2 and 6, 3 and 7, 4 and 8, and let's draw a quick diagram. And this one's going to need a few extra colors. So these two are corresponding angles. This one are corresponding angles. Again, they're both in the top right side. I guess this one here and this one here, they're both in the bottom right are corresponding angles. And let's go yellow. This one here and this one here are corresponding angles. They're both in the bottom left. And if you look at those angles, you can kind of notice, hey, all those pairs look like they're the same size. And in fact, if the lines are parallel, they are the same size. They are congruent and they are equal. So I could say that something like angle 1 is equal to angle 5. That wraps up the vocab. Let's actually put these words to use and turn the page over. We can do numeric problems with transversals. You can actually determine all of the other angles in the figures below by knowing only one angle, but only if the lines are parallel to each other. So looking at this first one, it says that measure of angle 1 is 120 degrees. So let me label that, 120. Well, what else can I label with that? Well, I know that angle 3 is a vertical angle, and that'll also be 120. And I know that angle 2 is a linear pair, so that's 180 minus 120, that's 60 degrees. And since 4 is a vertical angle, that'll also be 60 degrees. Now we just learned that angle 1 and angle 5 are corresponding angles, and so they're going to be equal. So 5 is also 120. 7, since it's a vertical angle, will also be 120. 6, because it's a linear pair, will be 60 degrees. And 8, again, it's a linear pair, it'll be 60 degrees. Do you kind of see a pattern going on here, almost like a checkerboard of how these all line up? Pause the video here and fill in these angles down below. Alright, so hopefully we've written down those angles there. Let's take a look at this next one. Pause the video here and try and figure out all the angles for this one and even the third one. Pause now. Right, so there's the answers to the second one. The third one is tricky because these lines aren't parallel. So not all those theorems from before hold. So if you haven't done the third one, pause it now and try it. So then when you look at number 3, you can fill in these first 4, angles 1 through 4, but actually you cannot fill in 5, 6, 7, or 8. That's because all the theorems that we learned on the previous page about alternate interior and corresponding only work if the lines are parallel. Since the lines here aren't parallel, you can't say anything about angles that are on a different intersection. So you just gotta leave those blank. Nothing we can put there.